Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will fine tune or train a segmentation model from a Kaggle dataset, right? So if you haven't seen my previous video in which I had explained all architecture about the UNet and we had implemented it using PyTorch from scratch, right? So please refer that video, it will help you to understand the content of this video, right? So let's get started. So first of all, for the UNet model, we are going to use a segmentation model PyTorch library, this one. So in the previous video, we had seen like the UNet model contains architecture like compression and then expansion, right? You can consider like encoder or decoder kind of architecture, right? So this library has implemented a multiple unit with the different kind of encoder layers, right? So if you see, this supports multiple model as an encoder. So there is a ResNet. So in the ResNet also there are multiple ResNet model, right? 18, 13, 4, 50, 101 and 152. And same you can see like DenseNet is there, InceptionNet and InceptionNet, EfficientNet, MobileNet. So these all models we had also cover in our previous videos, right? So basically what they are doing for the encoder part, they will use this model which is already pre-trained, right? So you can consider like trained ResNet 18 and it can extract the information or bottleneck feature, and then expansion block would be the similar kind of thing which we had seen in the previous video, right? So just they are replacing the encoder with existing pre-trained model, right? And the second thing, for this video we are going to use this data sets. So this data set contains the images of gastro instance time. So and it contains also mask as well. So this kind of images we have, and if I talk about the mask, so we need to detail this kind of mask. This kind of mask. So I'm not going into much detail about the data set, like what we want to segment and what each part is showing, right? So but my point of this video is we will learn how to train or fine tune a segmentation model, right? So you can get the better idea how to create a data pipeline, how to train it, and how to inference this, right? So first of all, for that we need to download this dataset, right? For the downloading, we will use the Kaggle hub. Okay, so let me install this Kaggle hub and segmentation model PyTorch. Okay, so it is downloading. So let's paste that code, which is the downloading code, right? Which we had copied from here. So let's download the dataset as well. And it will store at some location which is in the cache, but we can move that to here to just see the images and mask, right? So if you see this image, this contains the mask are in the two value basically, because it has only two class. One is the, you can consider like background, and one is the actual white part we want to detect, and the black is you can consider background, or we don't want that part, right? Basically this white is our area of interest, you can consider it. Okay, so you can, if you see this mask, this black has the value 0 for the pixel and this has the 1, or you can consider like 255 if you are considering the channel's pixel value from 0 to 255. This black part will be have 0 and this will be have 255, and when you scale the image it will be 1 and this black part will be a 0, right? Okay, so if you see the data set is stored here. Okay, so let's, I would say, move it here so we can also visualize, right? Let's say move, and yeah. Yeah, so dataset is moved here, so we can see here. Let's see, it will take some time. Yeah, so we are going to use this segmentation data. Okay, it contains two folders, images and mask. Okay, so now let's implement it. So first of all, I'm just importing few libraries which are the useful. Okay, torch, matplotlib for plotting, and torch, right? So let's first of all let's create a dataset class. Okay, so we can create a data loader that will be helpful to train the model. Okay, so first of all let me write the image directory. We are making some constant here, okay, which data loader can use. So let's say this will be our images, let's say mask directory, This will be our mask. Let's provide some other also, like batch size. Let's say batch size is equal to, we are using here, let's say 64. Okay, and let's provide the device as well. So device can be here we are using collab, so it will be a CUDA, but we are writing some dynamic code, so it can work on the CPU as well, right? So let's say CUDA if torch.cuda.is available, else it will be CPU, right? Now yeah, so these are few constant we want. Okay, now let's create the dataset. So let's say class segmentation dataset, and it will be used a dataset which we had imported right here, data loader and dataset. Sorry. Okay, it will contain like three method. One is init, get item, and the length. Okay, so which we will override basically. So let's say init self, and it will require like image path, basically a directory path you can consider, like, or we can think it like, let's say we will use list of images. Okay, here let's say image path, and let's say mask paths, and transform. We are not using transform because we will implement it is an inbuilt, so we just want like resizing the image and scaling the image. Okay, so let it be, let's say self.image path will be image path, self.mask paths will be mask paths, and self.transform will be transform. Okay, so this is about the init method. Now let's create length. Okay, so it will just return how many data points are there in the data loader. Okay, so let's say self, it will not take any argument, right? So we just need to return length of self.image, sorry, image paths, right? And now the main part, we need to create the get item method, right? Get item. Okay, let it be, we don't require this right as of now. Let's remove this part as well. So in get item, what we will do, we will read the image based on the index. Okay, so we are getting list here. Okay, image path and mask path. So based on the index, we will read the image and mask, and we will perform some transformation operation and return that image. Okay, so let's write that first. So let's read the image first. Image will be cv2.imread self.image path of index, and this cv2 basically read the image in the bgr format, right? So we need to convert it into the rgb because our model will learn from the rgb image. So let's say image will be cv2.cvt color, and we will pass our image, and it will be cv2.color bgr to rgb, right? Let me write bgr to rgb. Yes, this one. So now our image is converted into from bgr to rgb. Now we need to resize this, right, as per the model input. So we will use let's say ResNet 34 or 18. Let's write the image size will be 256. Okay, so let's say cv2.resize image, and let's say 256 and 256. Okay, so now our image is resized. Now let's scale the value of each pixel. So it would be like image, let's say star float, and let's use float 32, right? So float 32, and we need to divide it by 255.0. So as we are like dividing this image with 255, so all value will be between 0 and 1 because our minimum pixel value is 0 and highest pixel value is 255, right? 255 for the white and 0 is for black. So now let's say do the same thing for the mask as well, right? So I am just copying this here and it would be our mask, it will be mask paths, and same we need to convert into. So basically for mask we don't require this BGR to RGB, right? We just need to read the image in a grayscale because we have mask in the black and white format, right? So here we can pass, let's say cv2 dot imread grayscale, right? There is suggestion, yes, so grayscale. So we are reading the image in the grayscale, so it will be between 0 and 1. Sorry, it will be in the 255, but we are reading the image into the grayscale. We don't need 3 channels here, right? So then let's say mask will be, we are just expanding one dimension, expanding mask axis is equal to 0. So it will be like 1 comma 256 comma 256. Okay, now we need to, so first of all, now whenever we are dealing with the PyTorch, right, so torch model expects the channel first input. So if I say this will be the shape of, let me write here, so it will be like 256 comma 256 comma 3, right? But PyTorch expect channel first, so it would be, we need to provide the input in format like 3 comma 256 comma 256, right? So let's swap the axis basically. So we are converting 256 comma 256 comma 3 into 3 comma 256 comma 256. Okay, so we will use, let's say tensor, we will permute the axis basically. Let's say tensor, first let's convert the image into tensor and then perform permute 201. So basically second index will come here, 0th index will here, and first index will here, right? For the mask we don't require it because basically we have only one channel, right? And we had expanded at the first dimension, so it is already like this. Let me write here 1 comma 256 comma 256, you can think like that, right? Now for the mask we are just converting into the tensor, let's say torch dot tensor, and it will be our mask, right? So let's see this if we had done any mistake. So here is the image, okay, yeah, so here it would be the mask, right? Because we need to resolve mask. Then let's convert mask into the float, and yeah, we are extracting the mask. Now let's return image and mask. So this will be our a data loader, or you can say a dataset class. Okay, let me stop here for some time. Now let's create the dataset. So now we need to first image paths, right? So if you see, we require the list here, right? So let me write here the list. It could be a list, or let it be transform we are not using, so I am not defining that. So let's say image path will be, we can use all the JPEG images from here, okay, from the folder. So let's say glob os dot path dot join, what we had defined image d, right here. So if you see this image d, we will use HD and use all the JPEG image, right? Let's say JPG, and let's sort this list, so we will get the same list at the whenever we run, right? So it will help when we split it randomly, we can provide a random state, right? And it will provide the same output, otherwise it will provide a different output at the different time, right? So let it sort, right? Let's say sorted, let's say mask paths, this will be sorted. Let me copy this, right? Same thing we need to perform. Let's say it would be mask path, mask dir, and here also our mask is also in the JPEG format, and sometimes the mask in the PNG format and your image in the JPG format, so you can update the code accordingly, right? So now we have the list. So let's split it into a train test split, right? So let's say train images and train, sorry, let's say well images, which is a validation basically, and let's say train mask and well mask. Okay, and we are using train test split from the scikit-learn. Train test split, we will provide the basically, let's say, image path. Let me close it so we can get some extra space. Image paths, then mask paths. Let's say test size is equal to 0.2 and random state will be, let's say, 42, right? So let me write like this so it is more readable, right? Okay, so we are splitting our dataset into 80-20 split, 80% for the training and 20% for the testing or validation. Okay, now we need to pass this list into our this dataset class, right? So let's say train dataset will be segmentation dataset, and we provide this, let's say, train images and train mask, right? Same for the validation. Let's say well dataset and well images and validation mask, right? Okay, I should be there. Okay, so now dataset is created. Let's convert it into a data loader, right? So let's say train loader will be data loader. We need to pass our train dataset. Let's provide batch size, which we had defined here, right, above the batch size, and let's use shuffle is equal to true for the training. For validation we don't require, right, shuffling. So let's say validation loader, it will be use the well dataset, and batch size, let's say shuffle is equal to false. So this is about the data pipeline, I would say, or the data loader. Let's run this and check how it is working. Okay, yeah, so it is run. So let's plot first image, right? Let's say train dataset of 0. Okay, tensor object has no attribute, premiute. Okay, we have, there is a typo, so let's, it would be permute, right? Let's run. So it is, so it will return basically let's say img and mask, right? So let's run. Okay, so let's see the shape, image.shape. So it is basically tensor, right? So let's say size and mask dot size. So image is not defined. Okay, it is image. Yeah, so if you see, the mask and image both has the same size, right? So in this implementation, the input and output will be the same size, right? But in the paper, if you recall in the previous video, we had seen that in the original paper they are using different size output in the unit model, right? The input was around like 572 cross 572 and the output was around like 380 cross 388, right? Because like they are using, at that time they are using the copy and crop kind of operation to evaluate the model or calculate the loss, but here we are using the same size, so we don't require that kind of thing right here. Okay, so this is about the image size and image mask. Let's plot this so we can get better idea. So first thing, this image is basically a channel first, so we need to convert it into the channel last. So matplotlib can plot this, right? So let's say image dot permute, it would be, let's say 1, 2 and 0. So we are moving 0th index at the last, and let's plot im dot, sorry, plt.im_show. Same let's do for the mask. Im_show and the mask, right? Okay, so it is also like that. Let's do permute 1, 2 and 0. Yeah, so if you see here, this is our basically a mask. This is basically what we want to detect, right? And corresponding mask. So our data pipeline or our data loader is working perfectly. Now let's move to creating a model pipeline, right? So let's move to the model. Let me write here model. So first of all, our model will be, let's say, smp.unit. So we are basically using this library, right? So from that we are importing the SMP. Let me show you. Yeah, so here we are importing like segmentation model PyTorch as a SMP, and it contains the class which is unit, and which we need to provide the encoder name. Okay, so let's say encoder name, we use the ResNet34. Okay, you can use multiple models. There are multiple encoders are there, as I show you earlier, right? This all are just see the input image size according to the model and update your data loader according to, right? So this will be like encoder, and let's say encoder weights will be ImageNet. Okay, so this ResNet32, which is trained on the ImageNet, we are using as an encoder. Okay, so let's say in channel will be 3 here. If you are dealing with the only grayscale image, this would be a 1, and the class is, I would say, 1, because we need to detect one class, right? Other will be background. Now this is our model. Let's say model is equal to model.device model, convert it into the, load it into the GPU basically. Let's say device, and then we need to set our criteria, right? Criterion. So in terms like, you can say the loss which we will calculate. Okay, so let's say criterion will be nn dot binary cross entropy, binary cross entropy with logits, right? Logit slots, yeah. And okay, criterion, correct. Now let's implement the optimizer. Let's say optimizer will be optim dot, we are using Adam here. Okay, let's say Adam. Okay, Adam, and we will pass here model dot parameter, and learning rate would be, let's say, 0.001. Okay, so this is about the setting of the model. Let's run this and check it is working or not. Okay, you not get unexpected argument channel, so it would be channels, right? Okay, classes. Okay, here I also forgot the class. Okay, so now model is loaded and we are all set. Now let's implement the training pipeline, right? So let me write training pipeline. Okay, so now let's implement it. So first of all, how we will implement it, I will tell you. So first of all, we will write the training loop for the each epoch. We will calculate the loss and do the back propagation. That is a straightforward path. But we will save the model when the validation loss is lesser than the previous epoch, right? So we will save the best model, I would say. Okay, so we are writing in that manner. So let's say first of all, the best loss will be, float infinity. Okay, so whatever loss we will get, that would be a best loss for the first time, right? Now we need to write, let's say, epochs, right? How many epochs we need to train? So let's say epochs, let's me train it for the 10 epoch, and we will see the result. We can run for more epoch to get the better result, right? For the demonstration, I am using only 10 epoch here. Okay, so let's say for epoch in range epochs. Okay, so now let's say we need to first convert the model into training phase, right? So let's say model.train, and for inference we will use model.eval, right? Let's say train loss is equal to 0.0 float value. Now we need to iterate on our data loader, basically train loader, to train the model, right? So let's say first images and mask will be in train loader. Now images, mask, images. So when we are running the model on the GPU or CUDA setup, our data should be also in the CUDA, right? So we need to convert our images and mask as well into CUDA, right? The device, and let's say mask.to device. So these are our image and mask. Now let's say optimizer. So first of all, let's clear all the gradient which are the previously calculated. Okay, so optimizer.0 grade, and let's say output will be model and images. So model will predict the mask basically. Our loss will be criterion, which we had defined here, right? Binary cross entropy with the logits. So by with the logits, because we are not applying any sigmoid or softmax at the end on our model, right? So it will by default compute the sigmoid and apply the loss on top of that, right? So criterion, and just pass output and mask. Now we need to do loss dot backward and optimizer dot step, and let's increase the trend loss for the each batch size, right? So we are receiving the each batch here in the for loop, right? So let's say trend loss plus or equal loss dot item. So the dot item will convert it into our generic data type of the Python, right? So this is about the whole like back propagation and forward pass for the training. Now once we are done with all the or basically for one epoch for the training set, let's evaluate the model, right? So let's say model.eval, and then let's say validation loss is equal to 0, and we will do same, but we need to write like in the torch.noGrade, so it will not compute any gradient while we are evaluating the model, right? So let's say torch.noGrade, and we will do the same thing. Let's say for images, masks in a well loader, this would be the same. Let me copy it. Okay, now we need to create the output or calculate the output, which will be the model and images, right? So now our loss will be criterion, output and masks, right? Let's increase the validation loss with each batch size plus or equal loss dot item. Now let's say trend loss will be trend loss divided by length of trend loader. So what we are doing, we had calculated the loss for each batch and we are adding them into one variable which is start from the 0, right? So at the end we need to take the average. So we are just passing length of trend loader. Basically we are dividing our actual loss with the trend loader, so we can get the average loss, right? So let's say validation loss will be well loss divided by length of well loader, right? And let's print it. So print, let me use app string. So epoch will be here epoch from, let's say, epochs. So which epoch is currently running out of number of epochs, right? So we are just printing that, and let me write train loss will be our train loss, and well loss will be well loss. Simple, right? So now let's write the code to save the best model based on the validation loss, right? So let's say if validation loss is greater than a best loss, right? So if you see here, we had defined the float infinite, which is the best load at the first attempt, right? So whenever we are applying anything we are getting less than infinite, it will be best load for the first epoch, right? From next epoch it will work accordingly, right? So best validation loss, okay, what we had written, okay, so it is only best loss, not the validation loss. Let's say best loss. What we need to do, we will assign this validation loss to the best loss, right? This is the one thing, and now we need to save the model. So for saving, we will use torch.save, and we will pass the model dot .static, and let's say best model dot pth. Okay, so this is the name of our model, and this will, we are storing the static. Okay, and let's print as well, like we are saving this model, saving best model with validation loss well loss. Let's use the app string here, and we are just passing eth. Let's say best model dot pth, right? So this will be our training loop, and let's run this and check if we had done any mistake or it is working properly. Okay, so let's run for the 10 epoch. Okay, so torch size get 32 1, must be the same input size 64 1 256. Okay, okay, let's see mask output images. Okay, so we'll get the error at here, criterion output mask images. Okay, okay, here the mistakes, we need to use mask here, right? So let's run this. Okay, so I think it will run, so let's give it some time. Okay, yeah, so it is working. So first training loss is 0.29 and validation loss is 0.55. So first is model is save at best model.pth, right here one. So if we are getting validation loss less than 0.55, it will save the model. Okay, so here you go. If the validation loss is 0.36 here, we had saved the model, right? So let's now write the code for the inference while this model is training. Okay, so let me write here inference. Okay, so for inference what we required the model and visualize, we need to visualize it, right? So let's first write the function, and sorry for this disturbance if you are facing something, that there is a renovation is going on above my flat. So okay, so first of all let's say visualize and infer. Okay, it should be like infer and visualize, right? So let's write infer and visualize, right? It should be a. Okay, so for this method will take an argument as a model and image path, nothing else. Okay, and let's say a device if you want. Okay, so now first of all what we need to do, model will be in the eval format, right? So first read the image cv2 dot imread, whatever we had done in the data loader pipeline, right? We need to do the same thing here, right? So let me copy that lines, right? Okay, so if you see, these 4 lines would be same, right? Okay, let me write here. Now instead of okay, there is some indentation. Okay, yeah, so instead of this we will use image path here. Okay, now it is the image path, and we need to convert it into two device, right? So first of all, so now we have the image in the format like, I would say 3 comma 256 comma 256. But while inference we need to require one additional dimension, right, which will be the treat as a batch size, right? Okay, so it is not like this, it will be like 256 comma 3, right? So now first of all, let's convert it into the tensor. Tensor will be torch dot tensor, and we are passing the image. Now what we need to do, first of all we will convert this into a channel first, right? So let's say permute, and we need to pass, let's say second, 0 and 1, and then we will use expand dimension. So we are using unsqueeze method here. Okay, let me write the unsqueeze. So it is like, you can think it like inverse of squeezing. So you are basically adding one dimension at the 0th position. So now I will explain what is happening here, right? So now first of all we had taken this image, right, 256 comma 256 comma 3, and we converted into a tensor, and while we are permuting we are changing the dimension. So it will be like 3 comma 256 comma 356, which is a channel first, and now we are applying unsqueezing. So this output will be converted into like this. So 1 comma 3 comma 256 comma 256, right? So we are adding one dimension here as well. It will be treated as a batch size. Okay, so now let's say with torch dot no grade, as we are evaluating, right, or predicting something, so we don't require any grade here, right, gradients. So let's say output will be model image tensor, and output will be, let's say first of all it will return logits, right? So we need to convert it into sigmoid so we can get the probability of each class, right? So let's say torch dot sigmoid, and just pass the output. Now we don't require GPU, so let's convert it into the CPU and squeeze. So why we are doing squeeze here? So we had predicted over 1 comma 3 cross 256, right? So we are just removing this batch size. So it will be the squeeze and dot numpy, right? Now output will be, so whenever output is less than 0.5 we will treat as a 0, and when it will be greater than 0.5 we will treat it as a 1, right? So let's say output greater than 0.5. So this output greater than 0.5 will return a array of boolean value, right? So if we convert it into integer as type and we don't, let's say unsigned integer, okay, integer 8. So what we are doing, this is array of value of sigmoids, right? So once we are calculating the sigmoid, we are just applying the masking technique here, output greater than 0.5, so it will return a mask array, or you can say boolean array, right? When you are converting the boolean array into integer, it will return a 0 or 1 for the 0 for the false value and 1 for the true. So here you can consider it is a binary mask which we required as an output. Okay, so this will be our output. Now let's plot this, right? For the plotting we will use, let's say plot dot figure size. Okay, plot dot figure, and fixed size will be, let's say 10,5. Okay, Now we will use subplot. So basically we will plot three images. One will be the original, second one will be the mask, which is the binary, and third will be the overlapping image. Okay, so let's say plt dot subplot 1 comma 3 comma 1. So now let's provide the title as well, right? Plt dot title, let's say it will be the original image, and we need to plot the original image, right? Plt dot imshow, and it will be our image. Simple. Now we need to plot our mask, right? So let's say plt dot subplot, it will be 1 comma 3 comma 2. Plt dot title, it will be, let's say, mask, and plt dot imshow, we will provide mask here, right? Or you can see the output. Yeah, this one we are using it as an output, right? So it is the output. Now third one will be overlapping, right? So plt dot subplot 1 comma 3 comma 3, plt dot title, let's say overlap. Okay, then plt dot imshow image. Oh, okay. I think it will not print proper, because like we are converting this image into the float. But let's see if we require, we will update the code. Okay, plt dot imshow image, and let's say plt dot imshow, we are passing output, let's say cmap will be jet, and we are using alpha will be, let's say, 0.5. so we are reducing the opacity of the image. Okay, now at the end, let's say plt dot show, let's run this, how it is working. Okay, so if you see the model is trained for the 10 epoch, and loss is like 0.06, and it is 0.15. okay, so it is not bad for 10 epochs, right? You can run it for more epoch and you will get the better loss. Might be 0.0 here as well, right? 0.025, something like that. Okay, so now we have model which is trained and saved. So first of all, let's load this model, right? So let's say model dot load static, and we will pass torch dot load and the path of this file, right? Now model is loaded with the latest weight, which is trained, so all keys are matched and it is successfully loaded, right? So now let's play a sample image. Let's pick any image from here for a sample, right? So let's say image, copy. We can also run on the validation loader to get the accuracy or get the loss function, right? But we need to see the prediction, how we can separately run for the one image, right, without the data loader. So that's why I am writing like this. The second will be, let's say, mask path, right? We need to provide, let's say, mask image, not the mask we require. We don't printing the ground truth here. We will just, in this code, we are just printing the actual image, the predicted mask, and the overlap image, right? So mask will not required here. Now let's say visual inference and visualize. Okay, inference and visualize, we need to pass the model and sample image. So first of all, we need to convert model into eval format, right? Model dot eval. Okay, correct. Now let's plot this. Okay, inference visual missing one argument with this device. Okay, let's provide the device as well. Okay, so here if you see, So this is the original image, this was the predicted mask, and when we are overlapping, this kind of thing is happening. Okay, so from, if you see the original image, we are predicting this part, right? Let's do for the another image. We copy and provide here. Sorry. Yep. So here if you see, we are predicting this part, and this is the predicted mask, and this is the overlay image, right? So this is how you can fine tune a unit model for the segmentation task we had seen in this video. If you have any doubt regarding it, you can write in the comment section, we can discuss there. And if you like my video, please press the like button and subscribe my channel for more content. Thank you.